We start our analysis by looking at the long-term mean for GPP, both the spatial correlation and the temporal correlation. And for looking at the overall similarity, the multi-way similarity, we look at the MDS plot. And from this plot, we find that which are the most similar models and which are the dissimilar models. So we can see that CLM and CLM for VIC are appear to be close together and similar, and biome and DLEM are far apart, meaning they are dissimilar. So we select these two pairs of models from the control panel. As you can see here, CLM for VIC and CLM appear closer and they are far apart. And then we look at the matrix view. So as we can see, CLM and CLM for VIC have both very high spatial correlation, and like the temporal correlation is midway, while the spatial and temporal correlation for biome and DLEM, especially the temporal correlation, is much lower. So they appear to be much farther apart than CLM and CLM for VIC. For the next step, we would want to compare how the seasonal patterns. So we launched the GPP, the matrix view for summer, and then we select another view for looking at GPP for P patterns for winter, right? And then we select the same four models on the right, and we would want to drill down would find if the global patterns are similar to the regional patterns, and drill down to the region-wise patterns and look at the small multiples, and would want to do the same for winter. And here we can compare the different regions compare between global and regional behavior. For example, here you can see Europe actually disagrees with the global pattern, while for biome DLEM, while in this case Eurasia Boreal disagrees with the global pattern for winter season. On the other hand, for the temporal correlation, we see Eurasia Boreal disagrees with the global pattern for summer, while for winter there are quite a few regions like Europe, Eurasia Temperate, Australia, which have much higher temporal correlation than the regional temporal correlation is higher than global. For CLM for VIC, it's actually the regional patterns agree with the global pattern for both summer and winter. And also we see that the temporal correlation is on average lower in case of both summer and winter than the global patterns. The goal of this scenario is to look at the monthly correlation patterns and then look at the region-wise data distribution. So we start by selecting a month, say we select June in this case, and as we can observe, there are certain patterns that pop out. For example, visit looks a lot dissimilar, a lot less spatially correlated with almost all the models than some of the other ones, which are mostly highly spatially correlated. So if you want to verify how the region-wise distributions look like, so this is not showing a correlation but actual data, the region-wise distribution, so we can verify what we see in the matrix view with the parallel coordinates view. For example, we see that biome DLEM and DLEM CLM show a lot high spatial correlation, and we can verify that from the like the highly aggregated parallel lines between these two axis pairs, while the lines spread a lot in these two within these two axis pairs, and these are CLM visit and visit LPJ, and this is also shown here. CLM visit and visit LPJ show a lot less spatial correlation. Again, LPJ, GTEC, and GTEC 74 go higher, and as we can see, the lines are more parallel and tightly aggregated in this case. The other thing that stands out from this view is how much spread there is for the different models for NPP for the different models. So you can see visit, the spread for visit is much higher than almost all the other models. And also another thing which we find is the tight cluster of lines here, the red and orange lines going through for all the models, which signify that they are tightly aggregated for all these two regions, which are South America and tropical Asia, are tightly aggregated for all the models. And we can we can select the different months and see if this pattern is true for January, which is true, as we can see, or we can select a different month, in this case June, which is shown here, and we can see that this is kind of true for also June. And the other thing which we can do in this view is also reorder the different axes. Say, for example, we want to find what are the regional patterns for LPGA and buying. You can see that again the parallel the lines appear to be very tightly aggregated in parallel. If we find buying and LPGA here, we see a lot very high correlation, which verifies our finding in the parallel coordinates view. Also for LPG and DLM, you can see the highly parallel lines, which is also verified in this view. So the use of this view is twofold. One is to verify your look at the region-wise trends for the correlation patterns we see in this view, and then look at the spread and find some outliers and trends which is not apparent from the matrix view.